Hi. So today's video is going to be all about enzymes, and we're going to talk about what enzymes are made of, what they do, and the different factors that affect their activity. Enzymes are a very, very important part of our being alive. And so they're very important to learn about. Okay, so the title of our notes today is going to be enzymes. And I'm not sure how much you know about enzymes already. But the first thing I'm going to tell you is what enzymes are made of. And enzymes are a protein. So we're going to make a list. Enzymes are proteins. And as we have learned, proteins are made of amino acids. And so an enzyme is made of amino acids also. And it is a very important protein in our bodies. Made of amino acids, and each one has its own specific shape. Each enzyme has its specific shape. Okay, and as you learned before, all proteins are very complex and they're made of different amino acids, and it gets folded up in this very specific shape that does a very specific function. Okay, so the second thing about enzymes is that enzymes are what we call a catalyst. Enzymes are catalysts. And maybe you've heard that word before, and students use this word all the time. And what a catalyst is something that speeds up a reaction. So a catalyst is something that speeds up a reaction. And the reaction that we're talking about is a chemical reaction. Okay, so enzymes speed up chemical reactions. Okay, and so the job of an enzyme is to actually do the chemical reaction, and they speed it up. Okay, so the function of an enzyme is to do or facilitate a chemical reaction. Okay, and as I've mentioned in other videos, all chemical reactions can be categorized into two types. There is one type of chemical reaction where you are bringing pieces together to make a bigger molecule, or you have a bigger molecule and it gets taken apart to make smaller pieces. Okay, so I'm going to put this in parentheses. There are two types of reactions, and one is to build a molecule, a bigger molecule, and the other one is to break apart a molecule. Okay, and so enzymes either put together pieces or they take apart something big into smaller pieces. Okay, so that's what enzymes do. And so the way that an enzyme speeds up a chemical reaction is it lowers the amount of energy required for that chemical reaction to take place. So I'm going to say all chemical reactions need energy for them. Need energy, I'm going to say. And enzymes lower the amount of energy needed for the chemical reaction to take place. Okay, and the way that it lowers it is that, let's say, for example, we have two molecules that are floating around in the air. And these two molecules floating around the air, they're just going to be floating around for, days, maybe years. And one day those two different pieces will bump into each other just by chance, and then they will react and turn into one bigger piece. And so all the energy it took for them to find each other is a certain amount of energy. But what an enzyme does is it is this little machine that grabs one of the pieces, grabs the other piece, and puts them together. so that they don't have to like randomly just float around until they find the other piece. So an enzyme grabs the two, puts them together, and that is a lot less energy than for the two to just randomly bump into each other, you know, just by random chance. So that's how the energy is lowered. And that energy that is required for a chemical reaction to take place is called activation energy. Okay. So the energy needed for a chemical reaction is called activation energy. Okay. And so if we were to put this on a graph, okay, so I'm going to draw a graph. So let's see here. We have the y-axis, which is going to be the energy required. And then we have the x-axis, which is going to be time. So amount of energy. Okay. And so the lower it is, the lower the energy. So 0 here and a lot here. And then on this axis, we're going to say time. Okay. And so I'm going to draw two reactants. Excuse me. I'm going to draw two reactants. Okay. So here's one reactant. Here's another reactant. And let's say for this chemical reaction, we're going to have two pieces, which are those two pieces, and they're going to come together to form one big piece. Okay. And so I'm going to say that they have this much energy at this point. And so the amount of energy that they need to come together to make the product, hold on, let me put this here, is this much. So I'm going to draw a line. It's going to go up. It needs that much energy to form the product. And then the energy goes down. And then we have our two pieces are now together to make one piece. See, they're hooked together. Okay, so that line, which is not a very good line, I'm sorry, but it needs this much energy for this chemical reaction to take place. If an enzyme were around to do this chemical reaction, then it would need a lot less energy. So I'm going to lower that line so it needs less. So the red line is with an enzyme. The red line is with an enzyme. And the blue line is without the enzyme. Okay. And so you can just see by looking at these lines that without the enzyme, you need a lot more energy. With the enzyme, you need a lot less energy. Oops. Okay. So that is the second point that I was making. We're going to move on. Point 3. Point 3 is that every enzyme, which is this little machine, is very specific to what chemical reaction it does. Okay, so that's number 3, is each enzyme is specific to which chemical reaction it can facilitate. Okay. And so I'm going to draw a picture of an enzyme. Okay. So this is just a drawing and it's very generic. Okay. I'll show you a real picture in a second. But here is an enzyme and it's this large protein. Okay. Made up of amino acids. And you can see that there's like this little hole here. This little hole is called an active site. An arrow here. Active site. And the active site of an enzyme is where we put what is called a substrate. Okay, so I'm going to write that down here. Active site is where the substrate binds. Okay, and so let's say, for example, we have a chemical reaction. I'm going to draw one. Okay, so let's say we have hydrogen peroxide, and I'm going to draw it like this. It's going to be, so hold on. So I'm going to say there is hydrogen peroxide, that's a 2, and then H2O2 stands for hydrogen peroxide, okay? And there's an enzyme called catalase that takes apart the hydrogen peroxide and makes it into water, which is H2O, and oxygen, which is O2. Okay, so we've got an enzyme here, and I'm going to write the enzyme right here, catalase. Okay, and so this is our chemical reaction. Okay, and so on the left side of any chemical reaction is what we call the reactants. So I'm going to draw a little, and this is the reactants. Okay, and then anything on the right side of a chemical reaction arrow is called the products. Okay, and so the reactants is going to be manipulated by an enzyme. And in this case, the enzyme is called catalase. And so what happens is this reactant, which is H2O2, is going to go into the active site. And this is catalase right here. And catalase is going to take it apart and make it into water and oxygen. Okay. And so when a reactant goes into an active site of an enzyme, it is called a substrate. Okay. So this is also known as a substrate. Okay, so a substrate is any reactant that is going into an enzyme that is about to be changed. Okay, and again, an enzyme can either bring two pieces together to make one, or take one piece and take them apart to make two. Okay, so each enzyme is very, very specific to its shape, and that shape determines what substrate fits into the active site. So it can only do this catalase can only do this reaction because this active site can only fit hydrogen peroxide. Now that we have water and oxygen, those cannot be substrates for this enzyme because this can only fit hydrogen peroxide. So if these two products, H2O and O2, want to come back together to make hydrogen peroxide, you need a different enzyme for that. And that different enzyme is going to have an active site for the water and an active site for the oxygen, and it's going to bring them together to make hydrogen peroxide. But that's a different enzyme. Okay, so each enzyme can only do one chemical reaction. And that is because the shape of the active site can only fit a specific substrate. Okay, so the next point, number 4, is that enzymes are recyclable. Recyclable. That's not how you spell it, but let's see here. Recyclable, like that. Okay, so what that means is that this enzyme here can do this chemical reaction and then it makes the product, but the enzyme itself doesn't change. Okay, so the enzyme is changing a molecule. And so that molecule is now a new molecule, but the enzyme itself is not a new molecule. And because of that, this enzyme can do, more than one hydrogen peroxides in a row. It could just keep doing it over and over and over. So in that way, they're recyclable. Okay, so I'm just going to say that enzymes don't undergo any molecular changes. Okay, because the substrate does undergo a molecular change and becomes a product. Okay, and so every time an enzyme gets a substrate and turns it into a product, that is called a turnover. And each enzyme has a specific turnover number. Okay, so turnover is the amount of time that an enzyme can convert a substrate into a product. Okay, and each enzyme has its own turnover number. Okay, and there's a range. The range goes from anywhere between 1 turnover per second to 500,000 turnover per second. So the range is 1 to 500,000 turnovers per second. Okay, so some of these are very, very fast. Okay, so the next thing in our list is that enzymes, like I said, are made of protein. However, some enzymes have a non-protein component. Okay, so enzymes sometimes have a non-protein part component. Okay, and so those non-protein parts are what we call cofactors. Okay, so the non-protein part is called either a cofactor or a coenzyme. Okay, and so when you have your protein and without the cofactor, that enzyme is non-functional. Okay, so these enzymes are only functional when they have their cofactor or coenzyme. Okay, and these cofactors or coenzymes are usually a metal. Okay, cofactors or coenzymes are a metal ion usually. So it is important that in your diet you get a little bit of metal because these are cofactors for your enzymes in your body. And so every once in a while, it might be a good idea to like drink some tap water out of the sink because there are trace metals in that tap water that are good for your enzymes. And so this is why it is really good for your plants also that you use tap water, because these little tiny amounts of metal are really, really useful for your enzymes. Okay. And so when you have the protein with the cofactor together, this is called a holoenzyme. Okay, and that's spelled like this. Holoenzyme is the protein and cofactor together. Okay, and so I like to think of it as like whole, like a whole thing, but it's spelled like that. So I'm just going to draw like a little picture. So let's say we have an enzyme. It looks like this. And then it's got this little, but it needs the cofactor. So let's say this is the cofactor here. And it's this little metal ion. So the holoenzyme would be the protein part and the little metal ion that's attached to it. And in this way, the enzyme can control turning itself on and off. So if it wanted to turn itself off, it would take away the cofactor. And if it wanted to turn it on, it would add the cofactor. So it's just a way of regulating itself. Okay, and then the last thing is that I want to show you, I would just want to tell you that the naming of enzymes is very specific. So all enzymes end with the ASE. So naming enzymes, all enzymes end in ASE. So whenever you hear a molecule name and it ends with ACE, then you automatically know that that's an enzyme and that it's going to facilitate some chemical reaction. Okay. And so that's just important for you to know from now on, whenever you see that, or if you discover an enzyme one day and you name it, you have to name it with ASE. Okay. So the last thing that I want to do is I want to show you a picture of a metabolic pathway. So these are lots of chemical reactions in a row. And I just want to show you this. This is actually the Krebs cycle, which we're going to learn about. We won't get into all the detail, but I just wanted to share with you that this is called the Krebs cycle. And this is a molecule here, okay? And this right here is the enzyme. And so this molecule is called acetyl-CoA, and the enzyme is called citrate synthase. See how it ends with the ASE? And that's the enzyme that's going to take this acetyl-CoA and make it into citrate. And then this molecule is going to be facilitated by this enzyme to make this. And then this is the substrate for this enzyme, and this is the product. And then this product is now the substrate for this enzyme. And this enzyme is going to make this product. Okay. And it just goes on and on like that. And you can see that each chemical reaction is using an enzyme to perform that chemical reaction. Okay. And there's a substrate that goes into an enzyme, comes out as a product, which becomes a substrate for the next enzyme. And so that's how it works. Okay. So that's it for today's video, and I will see you next time.